Imagine this. Okay. You're having a pretty normal day, things feel fine, and then someone you really care about just sighs, like a simple sigh. But before you even consciously process it, your body just screams, danger. Your heart pounds, your chest gets tight, and this huge wave of emotion hits you, and it sticks around for hours. It feels totally out of sync with that little sound, you know?
Yeah.
It's like your internal alarm system is just cranked way, way up, and you can't find the off switch.
That's a really vivid picture.
Well, today we're taking a deep dive into exactly that kind of intense feeling. We're exploring the neurobiology behind borderline personality disorder, BPD. And the goal here isn't about, pathologizing. It's really about understanding that complex dance between our biology, our brains, and our emotional lives.
Absolutely. It's about understanding the why behind the intensity.
Exactly. And for this deep dive, we're drawing on some fascinating insights from Dr. Valentin Radoy. He's a psychiatrist and psychoanalytical psychotherapist whose work really sheds light on how early experiences shape us, especially our emotions.
His work provides a great lens for this.
It really does. So our mission today is to unpack the clues researchers have found about why emotions in BPD can feel so sudden, so overwhelming, and so hard to manage. Think of this as your shortcut to getting properly informed on something often misunderstood.
A really important topic.
Definitely. We'll start by looking at the brain's own emotional alarm system and its partner, the calming voice of reason. This is where it gets really interesting, seeing how biology wires into experience.
Right. So the brain essentially has these two key players for handling emotions. You can think of them almost working together or sometimes against each other.
Okay.
First, there's the limbic system, and particularly a part called the amygdala. You can picture this as the brain's quick-reacting alarm bell.
The threat detector?
Exactly. It senses potential danger, real or maybe just perceived, and boom, it floods your system with emotions. Very fast, very primal.
Got it. And the other player?
That would be the prefrontal cortex, the PFC. This is more like the brain's CEO, the executive control center.
The voice of reason you mentioned.
Precisely. Its job is to help us step back, think about things, put the brakes on those instant emotional surges, and, calm ourselves down. Perspective taking happens here.
So alarm and reason. But in BPD, our source material says there's often an imbalance.
That's the core finding, yes. Many, many studies point towards amygdala hyperactivity in BPD, meaning the emotional alarm doesn't just ring more often, it rings faster and much, much louder than in someone without BPD. It's like having a super sensitive car alarm.
Triggered by anything.
Almost anything, yeah. A strong breeze, maybe even a leaf falling.
Wow.
And then often at the same time, you see reduced activity in parts of that prefrontal cortex, the calming center.
Right.
Or the communication pathway between the PFC and the amygdala isn't as strong or efficient.
Okay, so the alarm is blaring.
Right, blaring loudly. But the system designed to check, hey, is this a real emergency? And turn off the alarm is maybe sluggish or the wires aren't fully connected.
Oh.
This creates what we call a frontolimbic imbalance. Powerful, easily triggered alarms, but a weaker, calming response.
That paints such a clear, almost physical picture. Going back to that opening idea, Anna, whose story is in Dr. Rodoy's work, she said, it's like my body screams danger before I even know what's happening. Even if someone just sighs, I feel it in my chest.
Mm-hmm.
Her alarm is clearly hypersensitive. Does that mean, physically feel it more intensely, too, not just emotionally?
That's a really sharp question, yes. Anna's description isn't just a figure of speech. It reflects this imbalance playing out both emotionally and physically in the body.
Okay.
And we see this objectively in brain scans. Functional MRI, fMRI studies, they consistently show the amygdala lighting up much more intensely in people with BPD when they see emotional faces.
Even neutral ones.
Yes, sometimes even neutral faces get interpreted as negative or critical. Or if they hear a tone of voice they perceive as harsh, that's the alarm, the physical response kicking in. And at the same time, those fMRI scans often show less activation in key prefrontal areas, places like the inferior frontal gyrus and the anterior cingulate cortex.
Those are important for?
Well, think of them as the brain's pause button and perspective lens. The inferior frontal gyrus helps you stop yourself, inhibit those immediate impulses, hit the brakes.
Right.
And the anterior cingulate cortex helps you notice conflicts, manage emotional clashes, basically step back and think, okay, what's really going on here? What's the other person thinking?
So if those areas are less active,
hitting that pause button or trying to see things from another angle becomes much, much harder.
wow. So you've got this hypersensitive alarm and an underactive calming system. It really explains how someone might genuinely misread a neutral face as angry or jump straight to thinking the worst in a relationship. Their brain is basically wired for a threat response.
It absolutely is. And that has a huge impact on how people perceive the world, especially social interactions. It shapes interpretations, leading to these conclusions that feel incredibly real and threatening internally, even if they don't match objective reality.
Hmm. Now, beyond that initial really fast alarm, there's another key piece, right? Something that explains why these big emotions don't just vanish quickly, like an echo chamber.
That's a perfect way to describe it, yeah. To understand this, we need to talk about a normal brain process called habituation.
Okay.
Usually, if you encounter the same emotional thing over and over, your brain kind of gets used to it. The emotional response naturally dials down over time. It habituates.
Like tuning out a background noise.
Exactly like that. You notice the ticking clock at first, then your brain filters it out, it learns it's not important.
Makes sense.
But, and this is critical for BPD, research shows the amygdala often shows slower habituation. The emotional response doesn't dial down efficiently, it stays high for much longer.
So the alarm gets stuck on.
Kind of, yeah. Once it's triggered, it struggles to disengage. Even if the threat is gone or wasn't really a threat to begin with, it's like that car alarm just keeps wailing and wailing.
Oh, man. That sounds exhausting. Anna's story again. If my friend didn't reply, I couldn't just shrug it off. Hours later, my heart was still racing. My whole body felt stuck in alarm mode. You can feel that persistence.
Yes, her experience really captures that impact of slower habituation. It helps us understand why the emotional pain can feel so huge, why it lasts so much longer than maybe other people expect.
And why just get over it is really unhelpful advice.
Completely unhelpful. The brain is literally stuck in that high alert state, just burning through emotional resources.
Okay, so we've talked about brain activity, how things are firing. What about the actual physical structure? Are there differences in the brain's build?
That's a really important question, and this is where the picture gets a bit more complex, a bit more mixed than with the activity findings.
How so?
Well, when scientists look at the physical structure, like the size of different brain regions, the results aren't quite as consistent across every single study.
Yeah.
Some studies have reported that the amygdala, our alarm center, and also the hippocampus, which is key for memory and managing stress, seem to be, on average, smaller in people with BPD.
Smaller? How much smaller?
One big review, a meta-analysis, found average reductions around 13% for the amygdala and about 11% for the hippocampus.
That sounds significant.
It does, but here's the important caveat. Other studies haven't found those same differences, especially when they carefully control for other factors,
Like what?
like a person's history of trauma or the medications they might be taking. These things can also affect brain structure.
Ah, okay. So it's not necessarily a universal thing in BPD.
Exactly. It suggests these structural changes might not apply to everyone with the diagnosis. They seem to be more common or maybe more pronounced in people who have both BPD and a significant trauma history.
That link with trauma seems really key then.
It points to a really complex interaction between our genes, our experiences, and how the brain develops over time.
That distinction feels crucial. It's not some simple broken brain idea.
Absolutely not.
And you mentioned earlier that amygdala hyperactivity isn't unique to BPD. We see it in PTSD, depression, anxiety.
That's right. Similar patterns pop up elsewhere.
So if some patterns are shared, what makes the BPD experience distinct? What sets it apart neurologically?
Great question. What seems to make BPD distinct isn't just one single thing, but rather the specific combination of these factors.
The mix.
Yeah, the unique mix. It seems to be the convergence of having those very sensitive, easily triggered emotional alarms.
Okay, the loud, fast alarm.
Combined with that slower calming down, the slower habituation we just talked about.
Right, the alarm staying on too long.
And then, crucially, the added difficulty in connecting those intense feelings to the reflective thinking part of the brain, that weaker PFC influence or connection.
So it's like a perfect storm. The alarm is loud and hair-trigger, it won't shut off easily, and the logical part that should assess the situation and hit the brakes is struggling to get through.
That's a perfect way to put it. A perfect storm of emotional dysregulation. This specific combination helps explain why the emotional shifts can feel so sudden, why the intensity is so high, and why it's so incredibly hard to let go. It's that interplay creating the characteristic struggle.
This brings us to something really important, something we always try to emphasize on the deep dive. These brain findings do not mean people with BPD are just broken.
Absolutely critical point. Yeah.
It's way more nuanced and actually more hopeful than that, isn't it?
It really is. The research isn't about finding a simple defect. It's about understanding this deep intertwining of biology and experience.
How they shape each other.
Exactly. What we're seeing is that early life experiences, things like childhood trauma, emotional neglect, invalidation, can actually influence how the amygdala and the prefrontal cortex develop their connections and how they communicate over time.
So the brain learns from its environment.
Profoundly, especially during those key developmental windows. If you grow up in an environment that feels unpredictable or unsafe, your brain might learn to be constantly on high alert.
As a survival strategy.
Precisely. That hypersensitive alarm system becomes a way to try and stay safe in a world that didn't feel safe or trustworthy. It's adaptive in that original context, but
But it causes problems later on when the situation changes.
right. It becomes painful and difficult when that same high alert pattern persists, even when the environment is safe. The brain is doing what it learned to do, but it's sort of overshooting the mark now.
That reframing is so powerful. It's not a flaw. It's a learned pattern, maybe an overprotective one.
An overprotective response, yeah.
Let's bring Anna's story back one last time because it shows this so clearly and how understanding helps. Her partner paused mid-sentence just to check a message. And instantly, Anna's chest tightened. Her mind screamed, "He doesn't care. He's leaving me." And even after he reassured her, that physical tension, that fear, it stayed for hours. The alarm was triggered and it just wouldn't reset.
Right, that classic pattern.
But what was transformative for her, according to the source?
What really shifted things for Anna, as Dr. Radoy's work suggests, was learning in therapy that her brain wasn't necessarily lying to her during those intense moments.
Okay.
Instead, it was overprotecting her. Her alarm system, shaped by all those years of unpredictability, was desperately trying to keep her safe from perceived abandonment or harm.
But trapping her in the process.
Exactly, trapping her in that cycle of intense, lingering pain. Realizing this, understanding the why behind the feeling, is often that crucial first step towards change, towards building new responses, new pathways in the brain.
Okay, so let's quickly recap the core takeaways for you from our deep dive today. First, people with BPD often have a more reactive emotional brain.
The amygdala, the alarm center, is extra sensitive. Goes off faster, louder.
Second, the prefrontal cortex, the brain's calming system, is sometimes less active or less connected.
Yeah.
Makes regulating those big emotions harder.
Right.
Third, brain structure studies. A bit mixed. But many do suggest a smaller amygdala and hippocampus in some, especially those with trauma history.
Important nuance there, yeah.
Fourth, those emotions tend to stick around longer. Slower habituation means the brain struggles to turn off the alarm.
The echo chamber effect.
And maybe most importantly, these aren't just fixed biological facts. They're shaped by this intricate dance between our biology and our early experiences.
A testament to how our brains learn and adapt, especially when facing challenges.
Absolutely.
You know, this deep dive really shows how deeply rooted our emotional responses can become,
Yeah.
often starting as ways to protect ourselves.
Yeah.
So if our brains can learn these patterns of high alert to try and keep us safe, even if it becomes maladaptive later, well, it raises a really powerful question for you to think about. What does this understanding tell us about the brain's incredible capacity to maybe unlearn those old patterns or to relearn new, more helpful ways of responding?
The potential for change.
Exactly. What might that mean for building resilience, for finding new ways to navigate those really intense emotions?
It's a hopeful thought, isn't it? That the same system that creates the distress might also hold the key to healing and transformation.